everyone, this is your educator from Ssb Safalta Academy and you're at the right place if you want to join the uniform services. In today's lecture, we will look at matter, characteristics of matter, various states of matters, transformation of various states of matters, and some terms which are related to the concept of matter. Alright, so let's get started. So this is the most basic thing that all of you must be knowing, that what is matter? Matter is anything that has mass and occupies some space, alright? So living things, be it human beings, plants, animals, or the non-living things such as your books, notebooks, oxygen, air, everything falls under matter. So please let me know in the comment section, what do you think? Is light matter or is it not? Now just quickly look at the various characteristics of matter. So matter is made up of particles. Alright. Now the next part is the particle of matters is very small in size. Alright. They are really small to be seen with our naked eyes. Not just naked eyes, they are very small even than our imaginations. Also, these particles have spaces between them. Alright. So as I showed you in the picture, if these are arranged this way, there is a gap, right? There is some kind of gap present between two particles of matters. Alright. So these particles are constantly moving. Please correct it. It's constantly moving due to kinetic energy. These particles attract each other. And there are three states of matter which are commonly known. Presently, two more states are added. We will discuss it later on in the slides. Next is that matter can change state from one form to another. We will also look about this further in the chapter. So as I told you earlier that matter is very small, right? And it is made up of very tiny particles. So you can see here. Also there is a gap between them. See, this is the gap. If these are the matters, so this is the gap which is present between two particles of matter. So now let's talk about diffusion. So that there are spaces present between two particles of matter. Now what happens is when different kind of particles mix with each other on their own, this process is called diffusion. Alright. For example, there are particles of oxygen. Alright. These are particles of oxygen and the sky blue ones are particles of maybe hydrogen. So what happens when this mix automatically on their own without any external force? This process is known as diffusion. Diffusion is lowest in solids, intermediate in liquids, and it is the highest in gases. Alright. Why so? Because the particles of solid matter are very closely packed. The space between the particles of solids is very less as compared to liquids, and it is maximum in case of gases. That is why diffusion is highest in the case of gases. Now let's have a look at classification of matter. Earlier matter was classified into 5 types. That was earth, air, fire, sky and water. These are also known as Panch Tattvas. This type of classification was very prominent in Indian philosophy and the ancient Greek philosophy. Alright, these were the classification in the ancient times. In the modern times, the classification varies a lot. Now the matter is classified based on two properties, that are the physical properties of matter and the chemical properties of matter. So now let's know the difference between physical properties and the chemical properties of matter. What are physical properties? Physical properties are the properties that can be measured and they have changing composition of the substance. For example, the color, the boiling point, the melting point, the hardness or softness, the density, all these fall under physical properties of matter. Whereas in case of chemical properties, the substance is classified based on its ability to react and form new substances. For example, consider the case of iron. Alright. So when we measure the size of the iron block or the boiling point and the melting point of iron. What is that? That are physical properties of iron. And when we talk about the process of rusting, right? Iron reacts with oxygen present in the surroundings. A layer is formed above the metal. It decomposes and this is called rusting. There are also other properties which are included in this, like burning, oxidizing, rotting, reducing, decomposition, and exploding. All this fall under chemical properties of matter. Now let's look at the various states of matter. So presently there are 5 states of matter. Earlier, matter was classified into solids, liquids, and gases. Then the 4th state was discovered, that is plasma. So the plasma state consists of super energetic and super excited particles in the form of ionized gases. Alright. You have seen the neon sign in bulbs and the fluorescence tubes, right? In the tube light, you have seen the fluorescent color. All that is plasma state of matter. And the 5th state is Bose-Einstein condensate. So the Bose-Einstein condensate is formed by cooling a gas of extremely low density. Talking about the plasma state of matter, what happens in this particular process is that, for example, consider a bulb, alright? There is gas filled inside the bulb, and when we pass electrical energy into this bulb, the gas gets ionized, alright? This gas gets ionized and this enters into plasma state of matter. We can conclude that high heat, right? When extreme temperatures are provided, then the matter gets converted into plasma state of matter. And it is opposite in the case of Bose-Einstein condensate. What happens? That when the gases of very low density are cooled extremely, right? They have to be cooled down to an extreme point that it is not possible in the natural conditions. This has to be performed in a laboratory under artificial conditions. So in this state, the particles of matter, they get converted into Bose-Einstein condensate. Now the concept of Bose-Einstein condensate is named after 2 great scientists. First being Satyendranath Bose, he is an Indian, and second being Albert Einstein. So Albert Einstein predicted that there is a 5th state of matter, and Satyendranath Bose was the person who did the important calculations to reach the Bose-Einstein condensate. So this is the reason that the matter is named after these 2 great scientists. And in 2001, 3 scientists reached this condition. They created this condition of matter and they were awarded with Nobel Prize. So I want you to comment down below the name of the 3 scientists. Let me give you a hint. All of them were from USA. Now here you can also look at the various examples of plasma. There is aurora, lightning, plasma ball, nuclear fireball, neon signs, welding arc. In all of this state, one thing is common, that high temperature is being provided, right? In some cases, like the neon signs and welding, this is provided by electric energy. In some other forms, it is provided by some different kind of energy. But the concept remains the same, that at very high temperature, any state of matter gets converted into plasma. And these are the other 3 states of matter which are very common. We have been studying about these from our very childhood, right? So what is solid? Let's have a look very quickly. Solids are rigid structure, they have fixed shape, they have fixed volumes, and they cannot be squashed. What is squashing? Squashing means to squeeze. Alright? So solids cannot be squeezed. Can you squeeze a wooden block? No, right? But you can squeeze a balloon which is filled with air, right? So we can conclude that gases can be squashed. Because gases don't have any fixed volume, they do not have any fixed shape, and they are also not rigid. They take up the shape of the container they are filled in. And between these 2 states of solid and gas lies a 3rd state, that is liquid. Liquid is not rigid, does not have fixed shape, but it has fixed volume like that of solids. Also, liquid cannot be squashed, that is, it cannot be squeezed. So you can see liquid has some properties similar to gases and some similar to the solids. So it is the intermediate state between solids and gases. I don't think that I need to explain all these properties of all these three matters, but it is quite important when we consider the exam point of view. So you can either pause the slide or take a screenshot of this. Alright. So the mass of solids is definite. In case of liquid also the mass is definite, and in case of gases also the mass is definite. But when we talk about the shapes, the solid has definite shape, whereas liquids and gases, they acquire the shape of the container they are filled in. All these are easy, right? So I want you to read it on your own. Just look at the last 2 points, that the intermolecular forces. Also it is called interparticle force. So it is very high in case of solid, and it is very, very low, like to negligible extent in case of gases. Now that we know that matter has 5 states, we must also know that matter can change from one state to another. Alright? And this can happen by 2 procedures, either with the effect of temperature or with the effect of pressure. Alright? So these are the 2 factors which result in the change of state of matter. So firstly, let's consider the case of temperature. So let's take the example of water. Water is a liquid, right? So when we provide heat to the water, right? When we provide higher temperature, what happens? It gets converted into gaseous state, that is water vapor. And when we reduce the temperature, it cools down and it forms ice, which is solid state of matter. And when we cool it down further, it forms the Bose-Einstein condensing state. And after the gaseous state also, if we keep providing high temperature, the matter transforms into plasma. So you can see at the extreme cold end, we get Bose-Einstein condensate, and at the extreme hotter end, we get the plasma state of matter, and liquid lights in the intermediate state. So now let's quickly know about this fact, that is conversion of Celsius into Kelvin. Both of these are units of temperature, right? And Kelvin is the SI unit of temperature. So let's know how to convert Celsius into Kelvin. So 0 Celsius is equal to 273 Kelvin. Now in other condition, what happens is, for example, 1 meter is equal to 1 kilometer is equal to 1000 meter. So when we say 2 kilometer, we multiply it by the other end, right? We get 2000 meter. But in case of Celsius and Kelvin, it is quite different. What we do, 0 में जितना भी add होगा, right? The amount that is added at the side of Celsius, the same amount will be added to 273 Kelvin. So at 1 degree Celsius, we get 273 plus 1, 274 Kelvin. At 100 degrees Celsius, we get 273 Kelvin plus 100, that is 373 Kelvin. So please take a note about this. This is quite important. So other than temperature, the second factor which affects the change of state of matter is pressure. Alright. As I have mentioned earlier, the particles of gases are loosely packed, right? When we apply pressure to these loosely packed atoms, they come closer to each other, right? For example, there is a bus filled with 10-20 people, and then there is a pressure applied that 50 more people get inside the bus. What happens? These 10 people will come close to each other because of the limited space. So when pressure is applied to gases, they change into liquid form. And when more pressure is applied to the liquid form, it changes into solid state of matter. Some of the examples are LPG and CNG. You know, right? So both of these are gases, but they are stored in the form of liquid, right? Why? Because they are stored under the condition of very high pressure. Because they are compressed to be stored inside the cylinder that comes at our home, right? When the matter changes from one state to another due to the effect of pressure, there are some terminologies which are associated with this change of state, right? So this is solid, these are gases, and this is liquid. So when the solids change directly into gases, alright, we have studied that with temperature what happens? Solid first transforms into liquid and then it further transforms into gas. But when we skip this part of transforming into liquid and the solid gets directly converted into gaseous state, it is known as sublimation. And when the gases directly get converted into solid state, this phenomena is known as deposition. This is very common that when the solid gets converted into liquid, we call it melting. And when the liquid gets converted into solid, we call it freezing. And now let's have a look at the solid gas association. In this case, when the liquid gets converted into gaseous state under the influence of pressure, we call it evaporation. And when the gases convert into liquid, we call it condensation. Alright, so these are the 6 terms associated with the change of state of matter. So you must remember all the 6 of them. So the next very important phenomena that is related to matter is evaporation. Okay? Evaporation is super important. So there are a few points that you have to keep in mind. Firstly, that evaporation is a surface phenomena. Surface phenomena. Please remember this. When the particles at the surface gain enough energy to overcome the forces of attraction that are present in the liquid and change into vapor state, this phenomena is called evaporation. Now again, this is a very important slide, that what are the different factors which affect evaporation. So first being temperature. Alright. So the higher the temperature, the higher the rate of evaporation. So it is directly proportional to temperature. Second is the surface area. So as I told you earlier that evaporation is a surface phenomena. So the larger the number of particles are present at the surface area, the higher the chances that the evaporation will be higher. So the rate of evaporation is also directly proportional to the surface area. Next comes the humidity. What is humidity? Humidity is the presence of liquid in air, right? When there is high humidity, that is, there is high amount of water in the air already, chances are the evaporation will be low. Whereas when the humidity is low, that means that the air is dry. So the chances are the evaporation will be very high. Alright. So in dry air, that is in less humidity, the evaporation rate will be high in less humidity and the evaporation rate will be low in high humidity. Same applies with the wind speed. What happens? That higher the wind speed, there are high chances that the wind will carry along the water present in the vapors and more space will be available for evaporation. So higher the wind speed, higher the rate of evaporation. So this is also directly proportional to evaporation. Only humidity is inversely proportional to evaporation. All the other factors like temperature, surface area and wind speed are directly proportional to the phenomena of evaporation. Now the application of evaporation is that it also causes cooling. Alright. So how does this happen? For example, this was the liquid, right? This was the liquid amount and there was some kind of heat energy present in the atmosphere which caused the surface particles of this liquid to get converted into gaseous state, right? So there was some kind of loss that was beared by the liquid particles So in order to compensate for that energy loss, these liquid particles, what will they do? The heat energy from the surface or the environment. So what are the steps of evaporation to cause cooling? It is surface molecules absorb heat, right? Yes. Then increase kinetic energy of molecules, and these overcome the force of attraction and escape into the gas and vapor state, right? This is what I have just told you about. And what happens when there is this decrease in kinetic energy of the remaining molecules? They cause cooling. Why? Because to compensate for this energy loss, they absorb the heat energy from the surroundings. And when they absorb the heat energy from the surroundings, it causes cooling. So these are the reasons why we wear cotton clothes in summers. Same process happens because cotton is a very good absorbent of water. It absorbs our sweat, and the same process of evaporation and cooling happens. The next one being when we keep water stored in earthen pots. Now let's look at the two very important phenomena, that is latent heat of fusion and latent heat of vaporization. So I told you that when we supply heat energy or we increase the temperature, the solids turn into liquid, right? But when the solid melts into liquid, there is no increase in temperature, right? The temperature remains the same throughout. Why does this happen? Because the heat energy is consumed for the transformation. To transform these solid particles into the liquid particles, some heat energy is required, and thus this temperature remains constant because the heat energy is not increasing. It is being utilized for the conversion. And this particular phenomena is called latent heat of fusion. What is latent? Latent means hidden. Similar thing happens in case of liquid to gaseous state of conversion. At certain point, when the liquid starts turning into gaseous state, the temperature stabilizes there. Alright, there is no increase in the temperature. Why? Because the heat energy is utilized for the conversion of liquid into water vapors. And this particular phenomena is called latent heat of vaporization. Now let's quickly have a look at what is 1 atmosphere. So the pressure of air in the atmosphere is called atmospheric pressure. So the pressure of air at sea level is taken into consideration. Thereby 1 atmosphere is equal to 1.01 into 10 raised to the power 5 Pascal. Alright, so this was important. I hope this video was useful to you. Subscribe to Ssb Safalta for more similar content. So after completing this video, you can visit our Instagram handle to take a quiz on this topic related to the PYQs and the expected questions. Thanks for watching.